this afternoon or this morning, wherever you are, I should be talking about a new feature we've added to Quad JSON to support tables. I'll start with a little bit of an introduction as to Quad JSON. Let's select the right screen. There we go. So JSON, as many people know, is derived from JavaScript object notation, and it's a format that is plain text, and it's used to transmit structured data. It's used all over the place: web interfaces, configuration files, all sorts. So here's an example of some JSON, and you can see here that we have got these braces indicate that we're defining an object, which in APL terms is a namespace, and within it there's a single item called A, and that defines an array, which in APL terms is purely a vector, and it contains 3 items: a numeric 1, a numeric 2, and a string 3. And in APL, you can present that as a character vector to Quad JSON, and it will create the data described, which in this case will be a namespace. And in it, there's an item called A, and the third element is a character vector called 3, containing 3. And you can do the reverse. You can pass the namespace back to Quad JSON, and it will regenerate the JSON text. And a couple more things of note. There are a couple of things defined in JSON which don't have an APL equivalent. There is a Boolean true and a Boolean false defined in JSON, which we don't distinguish from 0 and 1. So we represent those in a special form. JSON doesn't support non-simple scalars, so we create a non-simple scalar containing the text true to represent true. Another thing is that JSON only supports vectors. It supports nested vectors. As you can see there is a vector within a vector, but no higher rank arrays. And if you were to try and generate JSON corresponding to a higher rank array, you'll get told you can't. But we do have one option already that allows you to automatically split high rank arrays. It's a variant option you have to specify, but if you do, you can see we've automatically split that array. It's not the same data, but it's a good representation of it. So this is about tables. Tables are matrices, but they have a very important characteristic, and that is they've got headings and columns of the same data. So I've got a table here of a famous English musician, his chart history in the 1970s, and I'm going to use that data in my examples today. In fact, because there's rather a lot of that and I want you to see what's going on, I'm only going to use that much of it for most of the talk. So in APL, let's show that again. In APL, how would you represent that? Well, most obviously as a simple matrix. A matrix is very convenient, but difficult to work with perhaps if you've got to keep excluding the heading data. So in APL, you may be inclined to have a separate vector containing the headings, and there would be your APL representation. Or better still, because it's a more efficient mechanism, you might want to separate, you might want to invert the matrix. And by that, I mean have a vector of vectors where each of the inner vectors is a column in the matrix. So those are 3 APL representations that might be convenient in your application for representing that table. But in the JSON world, they go for a very different representation. Oh, I've got ahead of myself. Look, there's the headings. There's the vector of vectors. In JSON, it's quite a different approach they take. To store that data, you have an array of objects, and within each object, the column headings form the name of the data. So you see it repeated over and over and over there. Now, if we wanted to use JSON to communicate with an application which was expecting that format, and we've got one of the more traditional APL representations, if we were simply to send that data, we would have to do a complete conversion of the data. So let me show you what I mean. So I've come out of PowerPoint for a minute, hopefully start this up and do a little demonstration. So just to remind ourselves, this data that I'm showing on this window here is the data we're trying to create. And we need an array of objects. So let's create an array of objects. So let's start with an empty array and put in the first namespace. And then within that first namespace, we can put the name track and give it the value starman, the name year, give it the value year. And now the next thing we want to do is to create an item called chart peak, which is tricky because that's not a legal APL name. And Quad JSON does have the mechanism to represent names which are not legal. We can use this I-beam to convert that to a different form. It tells us that what we should name it is, as you see there. So we can create that item, value 10, and we'll repeat for the remaining 2 objects, like so. We've got a 3-item array of namespaces. And if we run Quad JSON on that, we get exactly the data we're looking for. So now our job is really to write some APL, which will take our APL representation that we had our table in, generate that, which of course is not something we really want to have to do. We've tried to make it a lot easier for you in Quad JSON. Let me come back first to show you this representation of the Boolean value true. Here I've got it in the middle of a vector of items. You can see that we've used this non-simple scalar to represent this item. What we've done in 18.2 is generalize that non-simple scalar form and we've added the ability to specify a code at the beginning, in this case 1. So in 18.2, not earlier versions, those 2 are exactly equivalent. But having done that, we can use this form to define other non-JSON types. And we're going to use that to allow table data in APL representation to be specified. I'll show you what I mean. So there is the data for that table that you saw in a CSV file. Let me use, I've got to go back to the screen. Let me use Quad CSV to read that data into the workspace. And you can see that doing that, I've got a straightforward APL matrix with the data, the first of the forms that I suggested you might want to store that in. Quad CSV can also give us the separate header. So that's T2 with a separate header. And it can give us the inverted matrix form. So that's T3. So I've got here the 3 representations of that data, which you may want to have that in your API application. So now you can see that I can pass that data directly to Quad JSON using this code 2. And in 18.2, the interpreter will generate the data in the correct form for JSON without doing any creation of that data under the covers. And we've supported all 3 of these forms. So the code 3 is the separate header, and code 4 is the inverted matrix and the separate header. They all give you the same results. Now, although it might be a little bit of an odd thing to want to do, this form is general and it can be used anywhere. So you can see here that I haven't just got the table in my data, I've got it as an element within a vector. So when I generate JSON of this, I don't know if you can see, there's the 1, then I've got the table nested within this array, and then I've got the 2. And you can nest tables within tables. So that's the 10 here. And if I change that to another instance of the table and generate that, well, it's difficult to see, but there is another table within the table. And that can carry on infinitely. Now I'm going very quickly here, so there'll be plenty of time for questions. Let's take the slightly larger form of the data, which I showed at the beginning. So this is a little bit more data. The reason that I wanted more is to show you another thing that you can do, and that is slice the data. So in this form here, I've got the code 2 as before, but I've also specified the rows and the columns of the data that I'm interested in. So when I generate the JSON of that, I will be showing only, oh, that's not right. What's happened there? Let's try again. I will be showing only those particular rows and columns. And to end the demonstration, I wanted to actually show this being used with an application that accepts the which accepts this JSON data. Now, the simplest way of doing it is to use this site here, which is kind of a test site. If I paste JSON into this window, I will get the representation of it as a table here. So in order to do that, let us open the clipboard from APL and generate the JSON for that entire table. I haven't selected any rows and columns this time. And that note about don't hit F12 is a note to me. Don't worry. It's this demonstration tool that I'm using is copying stuff to the clipboard, and so I don't want to mess it up. But I do hit enter. So on my clipboard, I've got that JSON now, and I paste it here. You can see it, and when I hit the run button, you can see it's nicely rendered on this web interface as the table I was hoping to see. Whoop. So if I come back to PowerPoint, the Zoom controls are hiding me. I have very quickly come to the conclusion. So we have generalized the non-simple scalar so that we've got a code which allows us to support many more non-JSON types as we need to in the future. And so far we've generated 3. One thing I didn't point out as I went through is that we can only at 18.2 export data in this way, importing it and working out that this array of namespaces is representing a table would of course be quite a different challenge, and so we will look at that as a future option if it becomes popular. It's more likely to be useful in the way that we've done it. So we've defined codes 2 and 3 and 4 for APL tabulate data generated as an JSON array of namespaces, and easily, and as I said before, without creating the namespaces under the covers. So it's a very efficient way of generating this table, as well as being a very simple way of doing it. And I can see there is a question. I don't know if John can come into audio or not, so I will assume not. And
I am able to come into audio.
Excellent.
I can read this question out if you would prefer it done that way. The question is, can you explain why the data precedes the headers?
That's a very good question, and it's one that is being discussed in Dyalog at the moment, because it feels wrong, doesn't it? The reason it does is because that is the way that Quad XML represents, Quad CSV represents a table with separate headers, but that doesn't necessarily explain that it doesn't explain why we did it that way for Quad CSV. We just did. And so now we're thinking, oh, that's wrong. But the question we've got is, should we remain compatibility with Quad CSV? And I thought it would be very odd if I had to reverse the order of those things when in that demonstration. Okay. And I think as APLers, we're quite used to reading data right to left. So yeah, it doesn't matter. You can look at either one, but it is possible. It is just possible that we'll change our mind before we release.
Okay, they're coming in thick and fast now. Next
Good.
question. While the code method is powerful and can be extended, could the format not be automatically detected by enclosing the table? I imagine the seemingly random numbers might confuse people. Also, why do the slicing using quad JSON when APL itself would be suitable?
Okay, good questions. So I'll address them both separately. The seemingly random numbers, yes. Well, we could, in this case, just enclose the table. We did consider that. We'd already just enclosed a character vector to represent true and false, and indeed null as well. There's no reason why we couldn't enclose a table and say, oh, look, that's a table, and generate it as a table. We realized there would become a point, though, when you could no longer tell what thing was that you were trying to represent. So we thought it best to introduce this code. Now, in the case of the character vector, true and false, you don't have to use the code. And indeed, when we generate JSON, when we generate data from JSON, we don't generate the code, we just generate the enclosed character vector. It would be possible to, I suppose, in this instance, to allow the code to be omitted for the tables, although we haven't done that. It's a good point. I'll put it down as something to discuss internally. But generally the answer to that is so that it becomes extensible further in the future. And so the questions have disappeared off my screen. Can you remind me the second one? Well, it was something about slicing the data, wasn't it?
Oh yes, so, right. Yes, the second part of the same question. It's from the same. Hold on. No, I fear that. Oh, also, why do the slicing using quad JSON when APL itself would be suitable?
Yes, good question. And there's nothing to stop you from slicing it using APL, of course. But one of the things about this feature is it doesn't generate the data under the covers. We wanted it to be quite efficient, and it's much more efficient not to slice the data before you present it to quad JSON as well. So it seemed like a useful and obvious extension.
Okay, thank you. And the last question that I've got in front of me at the moment is, did you show selecting rows and columns?
Did I show it? Yes, I did. Do you want to go back? It's in the demo, so I'll have to come back to the demo, which means I got to start the demo again.
You have 10 minutes, so
I have plenty of time.
So by all means, feel free to do that.
Okay, I'll go through it all. Oh, it's gone off the bottom of the screen. Hang on. Window. There was a better way of doing this, wasn't there? But not on live telly. Right, here we go. So there's the large table, and here is the slicing. So I've code 2, table, and I've wanted rows 3, 6, and 9, columns 1 and 3. So 1, 2, 3. So I should get that one, 4, 5, that one, 7, 6, 7, 8, 9, and that one, and then columns 1 and 3. So I won't get the year, hopefully. And I think I did the same last time I did this, didn't I? I lost it, and that's probably why it got missed. So there's the JSON that's generated for those 3 columns and so 3 rows and 2 columns.
Okay, and another question: can we use variant on enclosing the table with those option numbers?
Can we use variant on enclosing the table? I'm not quite sure what's meant. So you can say somewhere in this variant that is a table as instead of using the code. No, you can't do that. And part of the reason is because that doesn't have to be the only bit of data. As I showed you before, you can stick this anywhere amongst your data. So there we've got it within another array. And if you used variant, you'd have to specify what it is you meant and all sorts. I think that would be quite confusing. I'm not sure that I've answered the question that was asked.
If not, the question can be rephrased and it will come back again in the next few minutes.
Okay.
Another question is, what might you do in cases where there is no header data? Does that make any semantic sense even in JSON?
Well, yes, I defined right at the beginning of introducing the tables that a table has got headers. And in this format, it has to have headers, because otherwise what would you put here as the names of the items within the objects? So unless we came up with automatic naming, you know, column 1, column 2, that wouldn't really make sense. There certainly is no support for anything that hasn't got a header.
Okay. Again, if the answer of the question was more than that, then they have a few minutes perhaps to come back to us. Else, there's the chat later.
And of course, if they think that they're onto something, then or we, in reviewing this, think they're onto something, we should definitely consider them as enhancements.
Yes, of course. Sorry, you're not talking to me.
Well,
Richard, can you hear me?
Yes, Morten.
Is it not already the case that in the inverted form it's valid JSON, so we have to have code?
I think, let me think about this. It could, yeah, it isn't. It is, because there's no matrix.
I think we must have the code already because of the inverted form, which is just vectors of vectors.
Yes, you're right. It's only the matrix which makes it invalid JSON, and therefore.
Yeah.
And of course, we've already got this high rank array, which I briefly showed as well, where we automatically split the data. So even a matrix isn't an indication of a table.
Yeah. And I mean, doing the selection in QuadJSON is also for the case where, say, you have an inverted table of 100 million rows and hundreds of columns. You can do that in APL, but it would add quite significant cost to the operation. This is really imagined for servers that have large quantities of data to serve to clients that might be browsing through the data or making selections from a large quantity of data.
Yeah. Yes, that's a good point. Good.
Okay, hold on. There is, okay, a follow-up to the previous question. One could imagine a table that uses vector of vectors representation instead, for example, in cases where you don't have a header or the auto-indexing with a numeric name, as you mentioned. But I guess splitting and your other matrix format support would really cover those cases, question mark, which I think you've covered.
Yeah, the splitting is fine, because if you've got a table, that's likely to be a form that another application would like a simple matrix in. Yes, Aaron, you and I should chat more about this, because I think you're making a point that I'm missing, but yes, let's talk.
Okay, well, you can talk about that later.
Yeah,
and possibly well, maybe not the final question, but the last one on the list I have at the moment is, could not numeric codes be replaced by alphabetic codes?
Very good point. Now, APL is very much uses numeric codes. I mean, it's in Circle, and it's in a load of things that we've done since, like Quad DT. If you like numeric alphanumeric codes, then of course you can always define something, a name that you like to have the value 2, and use that in that place. Whereas the reverse isn't so true. So I'm not sure. I did notice that when we had the last presentation about the statistics from Ron, the statistical distributions from Ron, that his IBeam is using alphanumeric names, and I wondered whether that was better or worse.
And I think with some of the date time stuff, we take alphabetic codes, don't we, rather than numbers?
Well, the quad DT only uses numeric codes,
Oh, okay, my bad.
but the formatting function is very visual. So that might be what you're thinking of.
Probably. Okay.
Yeah.
That's the. That's all of the questions I have then.
Well, I'm very grateful we got so many, because I finished sooner than expected, and it's a good sign that people were interested. So thank you.